So hi guys, welcome back to my channel. So today I'll be solving this GFG problem of the day, which is non-overlapping intervals. Difficulty is marked as medium. Okay, so let's read the problem and try to approach this. So given a 2D array intervals of representing intervals of where intervals of I is equals to starting and ending point. Okay, we have to return the minimum number of intervals we need to remove to make the rest of the intervals non-overlapping. Okay, so let's see the test case. So now this is the 2D array which is given to us, and we have to tell that we have to remove some of the array elements so that the number of elements in the number line will become non-overlapping. Let me explain you. Like if I draw the number line, okay, so this is, let's say this is 1 to 2, so there is the range of 1 to 2. Okay, so there is the range 2 to 3, 3. Now 3 to 4, and again there is 1 to 3. Okay, so there is the 1 to 3. Now what we have to do, we have to remove some of the intervals. Let's say this, or this. We have to return the minimum number of elements that we can remove from here so that the range will become non-overlapping. You can see here clearly that this is an individual range, this is an individual range non-overlapping, but this is creating a hindrance in this because this overlaps with this and this. So what if I remove this one? Okay, so if I remove this, so it will become non-overlapping. So I hope this is clear and the question is clear. So the answer to this is 1. Okay, so means 1 comma 3 can be removed and rest of the intervals are non-overlapping. You all can see here that we have tried to remove the element which is bigger in size. Why? Because either we have options. Okay, so we have two options to remove. Let's say we can remove these two. Let's say these two. So let's remove this. Now the entire situation is become non-overlapping, and instead of this we can remove this one. Now also the entire system is non-overlapping, but what we have to choose, either we can remove two elements, this one or this one, or we can remove only one element, this one. We have selected the bigger range. Okay, so just keep this thing in mind. So I hope the question is clear. Okay, so now let's see how we can approach this problem. Okay, so now the first thing that we have to keep in mind that this array is in any order. Like it is not given that the array is in sorting order, but we have to follow some of the trends to know that which of the elements we can eliminate. Okay, so first of all we have to sort the elements. Now the questions come into our mind that which is the main part of the video, else everything is very simple. Okay, so why I'm saying this, because by sorting you can sort according to the first element. Okay, so by sorting you can sort according to the first element or to the second element. So we have two options, either we can sort according to the first element or we can sort according to the second element, but what we have to choose. Okay, so for that let me give you one example or one test case. Okay, so for example, let's take this test case. Array we are given to us 1 to 10, 2 to 3, 3 to 4, 4 to 5. We have to eliminate the minimum number of elements so that the complete range will become non-overlapping. So the thing which we have to keep in mind that what is the order of elements would be if we are going to sort the elements. So the first thing is sort according to the first element, 1, 2, 3, 4. Okay, so it is 1, 2, 3, 4. It is sorted according to the first element, and sort according to the second element means 3, 4, 5 and then 10. And we are going to calculate for both the situation that what are the elements that we are going to remove so that the complete range will become non-overlapping. So for this, let's see, it is giving 1 to 10. Okay, so 2 to 3 is lying in this range. Okay, so we are going to remove 2 to 3. So let me make a cross. We are going to remove. Now it is removed from the array. Let's say just forget it. Now let's move to 3 to 4. Is 3 to 4 coming in this range? Yes, 3 to 4 is also coming in this range. So let us remove this. Now forget 3 to 4 also. Now coming to 4 to 5. Okay, so is 4 to 5 coming in this range? 1 to 10? Yes, it is also coming. So let's remove this. So we have removed in total 3 elements from the array to make the like range non-overlapping. Okay, so let's come to this example. So sort according to the second element. You can see here 3, 4, 5 and then 10 sorted according to the second element. Now let's compare. Okay, so is this 3 to 4 coming in this range? So is this 3 to 4 coming in this range? No, because 2 to 3 is this and 3 to 4 is this. So it is not coming. So we'll not be removing it. Now let's move forward. So is 4 to 5 coming in this range? Is 4 to 5 coming in this range? No, this is also not, because 3 to 4 is this, 4 to 5 is this. So it's not overlapping. So let's remove, let's move forward. Now, is 1 to 10 coming in this range? Yes, 1 to 10, because you all can see here 1 to 10 is this, and 4 to 5 is coming in this. So we'll be removing only 1 to 10. So we'll be removing only 1 to 10. So in this, we have removed only 1. Now, what is the crux of this video? We have to sort it according to the second element. Why? Because whatever the maximum element that we are getting at the second value will come at the last. So because we want the smaller chunks to be completed earlier, then the larger chunks to be removed later. That's why we have sorted the array according to the second element. Now, what is the approach of solving this problem is, okay, so one by one we'll be standing at this particular index, and what we'll be doing, we'll be checking this. Okay, so we'll be taking the 3, see, we'll be taking the 3, and we'll be checking the first element of our next iteration. Okay, so let's say we take the last as 3. Now let's say last, currently our last is this. Okay, and our new iteration is, our next iteration is 3. Okay, so we'll be checking the first element of our next iteration. If iteration of I0 means first element of our iteration is less than last, it means that if it would be 1, then it means that it is overlapping, because 2 to 3 is this, 2 to 3 is this, and if it would be 1 to 4, then it would be this, 1 to 4. So if last element of our next iteration is smaller than this last value, like the iteration, like this is our iteration, and if it is smaller than the last value, then it means that it is overlapping. Okay, I hope this is clear. Now, okay, so is 3 less than the last value? No, it means that, let's move forward. We'll be updating our last 2 here, and our next iteration is here. Okay, so next is 4, and our last is 4. Okay, so is 4 less than this? No, it's not less. So again, we'll be moving forward. Our last is this, and our next iteration is this. Okay, so let me remove. Last is now 5, and our next iteration is 1. Okay, so is 1 less than 5? Yes, 1 is less than 5. Why? We can see here the range is 4 to 5, and our new range, which is 1 to 10, its first element is 1. So what we get to know from here is it lies something around this 1 to 10. So it is overlapping. Then what we are going to do, we are going to remove this element, and we are moving forward. So this is the basic approach we are going to follow. So let's now move to code. Okay, so what I'm doing here, so first I'm sorting the elements in according to the second element. So what I'm doing, the basic syntax is intervals dot begin and intervals dot end to cover the complete range, and then this is the like parameter that I'm passing, so that I came to know that on which basis I'm going to sort the array. So let me tell you one thing. So in this parameter, what I'm getting, every time I'll be getting 2 comma 3 and 3 comma 4. Okay, so every time this is vector A, this is vector B, every time I'm getting these two values for these two small arrays, and what I'm returning, so a of 1 should be less than b of 1. Okay, so if a of 1 means this is less than b of 1 means this, then only it will return true and it will sort accordingly. So this is what I'm doing. I'm sorting the array based on the second value. Now I have initialized the count variable, which will be storing that whatever elements that we are removing from the array. Okay, so last means I have initialized this first value. Okay, so initially what I'm doing, so I have initialized my last as 3, this first index of our interval, so that I'll be starting our iteration from this index. Okay, so now last is equals to intervals of 0 comma 0 1. Okay, so this is the 0th index, 1 index, 2 index, 3 index, this is the 0, and in 0th index this is the 1. Okay, so this is the 0th index and this is the 0 1 of that. So 0 and 1, so it will be 3. So last is initialized as 3. Now I'll be starting my iteration from I is equals to 1 to intervals dot size. So okay, so no need to do this flat. So what I'm doing here is, so if last is greater than intervals I comma I0. Okay, so what is it? So if intervals of I0 is less than last, it means that we have to increase the count. So we can see here, okay, so we can see here that 1 means if this the iteration is standing on this and our last value is this. Okay, so if this one is less than the last, then we are removing this. It means that we are increasing the count. If it is not the case, that means our last is this and we are standing on 4. Okay, so If this is not the case, means 4 is not less than 4, means iteration I of 0 is not less than last, then that means we are updating our last. We'll be updating our last to this, and next our iteration will be pointing to this. Now if 1 is smaller than the last, that means if 1 is smaller than the last, then we are removing this. It means we are increasing our count, else we are updating our last, and finally I'll be returning the count. So let's run the code. And by the way, the time complexity of this problem is big of n log n, because we are performing the sorting. So okay, so all the test cases were passed. So thank you for watching and having patience. So thank you.